page, the live stream.
You know that she is.
You are blowing my mind. She's married to
Perfect. Is it the same thing that you sent me? Because I have
it's slightly different. Slightly different. I just reduced some things and some of it.
Wow.
This is the problem with modern computers is there's no
doesn't like your USB. There we go.
There we go. So if you just pull it out of there,
Perfect.
it's just a PDF. And just put it in the stream.
Thank you. Thanks a lot.
Okay.
So I'm just going to drop it and then we'll get started.
Yeah.
Which directory did you guys do for yourself? RLP. Okay. In ID text. And just on the dictionary. Okay.
Good. Yeah? And you can hear us?
Yeah. Very clearly. What did I say? NRT.
Excellent. Okay. Great. Well, is everyone here? Should we gather anyone, or does anyone know of anyone that's in the?
Okay.
Okay, great. So welcome everyone. Welcome, Siwei. And welcome to everyone on the live stream. It's my honor and privilege to bring you Arthur. Arthur is professor who splits his time between the politics department at NYU and the data science initiative. As I was saying to Arthur earlier, and you guys would have noticed, as soon as we started discussing text today, a bunch of Arthur's papers were dumped on the Slack by people from various institutes. So he really is a leader in this field, and it's our honor to have you here. We have about an hour and a half, and I think Arthur is happy to take questions as he goes. So just raise your hands to interrupt him, and then hopefully we'll also have a brief Q&A in the after the talk. Arthur, it's possible that we'll get some questions via Slack from people who are watching on the live stream. So either Broom or I might interrupt you as well during the talk. Great, thank you very much.
Thank you very much. So it's great to be here talking about some text work I've been doing. So this is co-authored work with Ken Benoit, and he's at London School of Economics, and Kevin Munger, who actually is no longer at NYU. He's about to go to Princeton to be a postdoc, and then he'll be an assistant professor at Penn State in about a year from now. So we're talking about textual complexity today, and this title, sounds a bit abstruse, I guess. But what we're really thinking about is this problem of measuring dumbing down. And so whether dumbing down has really happened, to the extent that it's happened, and so on and so forth. And that's interesting in some sort of democratic theory sense for reasons I'll talk about in a minute, but it's also really interesting from a measurement sense. And so the way that we think about that problem in terms of how we go about measuring things informs our paper today. So as a sort of aside, before I really get into this paper, I'm really pleased to see things like computational social science institutes taking place. So in my career, right, I started out thinking about doing basically formal theory, which is essentially, game theory. And instead, what I decided to do was something called methods. And at the time that I made this decision in the early 2000s, which was when I was starting my PhD, it was actually really, really unpopular. Or not really unpopular, but it was not where the really smart people worked. And what I'm sort of thrilled to discover is that, in some sense, sociology in particular appears to have avoided this, not dead end exactly, but has avoided this area and is kind of going straight to thinking about computational social science things. And I hope that this work will be sort of right within that area. Okay, so I'm going to start out making some comments about what we call anxieties of democracy. So the idea here is that we're very anxious about sort of numerous things in the way that democratic societies are structured. And it's not hard to find these sort of doomsday pronouncements. This is just on Amazon, a very kind of quick search, I think, of dumbing down or something, where you have people talking about the idea that, the way that we live, the way that we have social media is making us very stupid, right? So there's this idea that blogs and MySpace, you remember those days, right, are making us very dumb. And that furthermore, Google is also kind of ruining us and making us dumb. Now, this is sort of not a new concern. This is someone who's now a footnote in history, but he's famous in sort of the development of British politics because he was very opposed to democratization. And this is an interesting quote from him. What they're doing at this time is in the 1860s, and they're discussing should democracy be rolled out to the urban working classes, working class men in particular. And he's very opposed to it. And the reason he's opposed to it is partly because he claims, look at the United States, it hasn't worked there. Of course, what he's talking about is the Civil War, essentially. But he also has this sort of slippery slope argument that if you go along these lines of having democracy, this is going to be terrible because essentially the people are sort of far too dumb to kind of cope with democracy. Now, I can tell you, obviously, this isn't a new concern to Western thought either. So here's Plato. He wasn't a big fan of democracy either. And he's talking about the idea that it's going to be sort of pretty lawless and everyone will be on an equal footing with everyone else. This will kind of kill off the expertise of governing, so we won't have these philosopher kings. It's terrible, right? And this is something that's been sort of under the cover of the development of Western democracy since its earliest times. So what's the sort of evidence for this? What's the evidence for dumbing down, at least in the sort of political sphere, right? So we have this notion that this is going to happen, that it's going to be a problem. What's the evidence for this? Yeah, a lot of the evidence boils down to these types of comparisons. So somebody will take a State of the Union speech, from the 1920s or 1930s, from 1940 or maybe 1936 in this case. And here's Roosevelt doing a State of the Union address, and he's talking about national income, and he's talking about policy and agriculture and so on and so forth. It's quite involved. It's quite, it's quite rarefied, right? Some of these terms that he's using, right? And then he's giving these very precise predictions, thinking about new taxes and so on and so forth. And this is often contrasted with this type of statement, right? So some say my tax plan is too big, others say it's too small. I respectfully disagree, right? And of course, this is from George W. Bush. Who else could it be from? And you guys might remember a time when we thought he was a bad president. Obviously, times have changed, right? You took a very different line on children in cages. But there's this idea that this represents the old world where people used to be very precise with their language, right? And now we're in this kind of vague morass, and what does this mean? And it's very simple, and this is evidence of dumbing down, or indeed maybe this is what's leading to dumbing down. And you also see this type of thing. So this is from the Guardian newspaper just a couple of years ago. And they're talking about the fact that State of the Union addresses, very popular, by the way, to work with State of the Union addresses because they're an unusually complete time series. So we have one per year, sometimes more than one actually, since the founding of the Republic. As I say, they're essentially, you can get one every year. And what is this graphic showing? Well, what the authors think it's showing is this kind of dumbing down of American politics in particular. So this was in the Guardian. It's the official newspaper of people who hate America. And what you can see is that, I'll just explain it because I'll get into more detail in a minute. What's being estimated here is the high school grade level that would be required to understand this passage, but I'll actually get into that in more detail. It's very important for what we do next. And the point is that it's kind of declining over time. Okay? So the questions that my co-authors and I thought about are partly about behavior, then also partly about measurement, right? So we know that in a minute I'll introduce something called the reading ease or the flesh reading ease is increasing. So that turns out to be basically the inverse of the grade level. So if reading ease is increasing, then lower grades find it easier to understand. All right, so, but what we were worried about was whether or not it really made sense to sort of make these readability comparisons over time. You know, for a start, I mean, it's not hard as social scientists to think about why this might be problematic. So for one thing, right, you know, it's worth thinking about when these reading ease measures were invented. And as we'll see, they were mostly invented in the mid-century. They weren't really used for the types of political texts that we care about, right? So we're sort of applying them out of domain. The topics of the speeches aren't constant. The way the addresses are delivered aren't constant, right? These are sort of basic social science problems, and just kind of throwing up a line graph is pretty unhelpful. Now, perhaps more interestingly, and this isn't something I'm going to answer today, is why have we seen this, if indeed we've seen a simplification of text, right? Why have we seen that, right? What's the story that would explain that? And it's not as sort of simple as you might think. So you might think something like, well, maybe there's just sort of more demand for sort of simpler things, right? But that's surprising in the sense that education is generally increasing. Certainly in the 20th century, IQs were increasing on average, right? We might expect people to demand more complicated material, right? So we're not going to really answer that, but I think that's an interesting question of itself. So I'm going to define some terms, and that's going to be important for what we're actually going to try and measure. So in this paper, we're a bit fast and loose about what is sophistication, what is complexity, what is readability. But sophistication, at least in political science, is a property of individuals. So you guys are all very sophisticated consumers of news, or you're very sophisticated consumers of politics, because, right, you have numerous cognitions, which basically means you have numerous thoughts about politics. You're not, on just one thing. They cut a wide substantive swath, right? So there's this idea that you have views about, everything from, say, what the Supreme Court should do in this particular case, what taxes should be, so on and so forth, right? And they're also highly organized or constrained. So we have this idea that individuals who are sophisticated have some notion that their thoughts are they kind of make sense together. They sort of have this kind of coherency. But obviously, this is a property of individuals, not texts, right? So when we talk about political sophistication of text, it's a bit awkward because that's not really what was intended by that definition. So what's complexity? Well, so complexity is something that's very popular to discuss in computer science, and it's certainly where that field meets linguistics. And what complexity means essentially is that it's how much of your brain, your computational resources do you need to comprehend, to process a sentence or to process a document. And you can think about why some things might be harder than others. For example, it might depend on whether the subject and object of the sentence, turn up in a way that you expect. Are they swapped over? Is it passive voice? You have to remember what the subject is as you wait for the object to occur, or something like that. And then sort of finally, the easiest thing to define, right, is the readability of the text. So readability is literally that, right? It's just the ease with which, how much education do you need to comprehend this text. So this idea of comprehension is going to be a slightly tricky one for us, because in the end, we're just going to ask people, could you comprehend it or not? We're not going to test them on it, but I'll return to that momentarily. Okay, so this idea here has spawned what I would call a very straightforward measurement literature, and it's this that we're going to try and contribute to in this paper. There's nothing new under the sun in this world, all right? So straight off the bat, I would say that there are well over 100 years of thinking about how to measure readability. And as you can imagine, the prototypical task was trying to assign texts to school children, right? So you had a school child who was 7, you go, what text do I think this person could plausibly read? And I would say by far and away the most popular, certainly gets the lion's share of citations, is this measure suggested by Flesch in 1948. And it's called the Flesch reading ease statistic. And that is the statistic, okay? So the score of a document is equal to this constant minus this number multiplied by the total number of words per sentence, okay? Sorry, the words per sentence on average. And then subtract off this number multiplied by the total syllables divided by total words, i.e. the average number of syllables per word. So probably what you're thinking when you look at this is that this seems, kind of like a regression formula or something like that, right? So it looks like we've got a constant, we've got some coefficients, we're multiplying them by something that we can calculate from the text. And actually, that's exactly where it came from. So what Flesch did was he had all these school kids, and he asked them to read these texts, and then he checked their comprehension. He put together a regression afterwards, and this is the output of that regression. And we've been using this for the last 70 years to continue to assess, how readable some particular piece of work is. So at the very start, I showed you some stuff at grade level. So the grade level, sometimes called the Flesch-Kincaid score, comes from a transformation of the FRE. But I'm going to work in this space today, the FRE space. It's typically better cited, and it's also has some nice sort of continuous properties. The other thing I like about it is I don't, for me, I think up in the United States, I don't always find the grade levels very natural, but this at least has a more natural interpretation. Although, as we'll see, the interpretation is tricky in some cases. So here are some guidelines about what the Flesch reading means does. These, again, as you can imagine, it's really trivial to calculate this for a text, right? Here's you guys, you generally probably read and write things that are between 0 and 30. They're considered very difficult. About 28% of the population of the United States finds that stuff readable. And then we go down, right, and this is like the very minimum that you would expect, so somewhere between 91 and 100, something like that. So 100 is kind of the easiest 4th, 5th grade reading standard. Here's some examples, right? Obviously, this can go wrong in some cases, right? So here's a piece from Joyce's Ulysses. Molly Bloom's Soliloquy gets a score of -800. It's very difficult to understand. What is the reason for this?
Yes.
Sure.
There's just a lot of repetition.
Yeah, yes, and in particular, basically, there's no punctuation, right? So it's like one run, like long run-on sentence, So here's where the mean political science article is. That's about 33. This is my work. It's about 37. I don't know if that's good. I'm not sure if that's good or bad. I'm easier to understand than the average political science. Life insurance requirements. Here's the New York Times. Here, any day now, they're going to bring out one for adults. There's a Reader's Digest, Al-Qaeda press releases, children's books from here somewhere. So in a separate project, I had a look at some data of inmate statements from Texas. Of course, these are very short and they tend to be quite depressing, but they're also very simple. The people typically don't have much education. And then something like this entry right here scores 100. So what you'll notice straight away, right, is that in some sense, right, this is quite easy to read, but that's partly because you know words like entry, right? And I mean, in particular, the entity that I'm referring to is, this self-defined thing. But what you may immediately see is that there's something odd about this, which is that, we can imagine a 4th or 5th grade child might struggle with something like entry because it requires some sense of a database, and this is a field and a record or whatever. But we'll come back to that momentarily. So the first thing that we actually did in this project in general, and this was in a separate piece of work, right, was that we had a really good look at this State of the Union thing. It was fundamentally, we didn't believe this. Is public discourse becoming dumbed down? So probably not, right? So the first question is, how representative is the State of the Union change relative to other corpora which we might be interested in? So an increase here means it's getting simpler over time. So if you keep an eye on this black line, right, this is the State of the Union. So that is increasing, okay? So if you take that Flesch score seriously, it certainly is increasing. These are proclamations, presidential proclamations, executive orders, that type of thing. They went through a huge surge around 1950 in terms of easiness. But for most other of these time series, it's not really obvious that they're getting dumbed down, right? So, for example, if you take something like Supreme Court decisions, this purple line, right, and you go back to 1800 when they first start bringing, these haven't actually changed that much, even on this measure. And the same goes for things like this orange line here are Nobel Prize announcements, right? So when or if, I guess, you get the Nobel Prize for Literature, right, there's some statement that's made about why you deserve to win. And you can see that's fairly constant over time, right? So if you want to make big claims about culture being dumbed down, right, you have to sort of simultaneously explain why these particular time series are changing, like the presidential ones, right, but other time series aren't changing very much at all. So then we started to think about, what actually could be driving this, even in the State of the Union case, right? So we first looked at just syllables, right? So it is true that the length of words in terms of syllables is kind of falling over time, but it didn't begin to fall really until about 1950. And frankly, the number of syllables used in these other kind of time series is actually increasing over time, okay, on average. Then we looked at sentence lengths, and this is kind of where the real action is. All right, so claims about dumbing down basically boil down, in many cases, to saying that sentence lengths have fallen. In some cases, this is precipitous. In some cases, it's not. But it's also worth thinking about why sentence lengths have fallen, right? So if you watch something like a State of the Union address, there is this expectation of getting lots of applause every time you finish a sentence, right? And that simply wasn't the case historically. If you watch like Carter giving a State of the Union address, no one applauds. There's a little bit of a Carter fixed effect there, I think. But it's not such a popular thing where you kind of hit one sentence, everyone applauses, hit another sentence, everyone applauses, right? So, okay, so let's get back to this kind of measurement problem, right? So that's just a quick, discussion of thinking about State of the Union on its own terms. So there has been this attempt to think about how rare terms are, right? So, in some sense, if a term is rare, you don't see it very often, that tends to be something that we think is quite difficult, right? So these guys here, Dale Chow, they looked at the percentage of difficult words, and the argument here is that, well, if something has more difficult words, then basically it's harder to understand. But for them, it's completely static, right? So they updated it once in the 1990s, but essentially in the 1940s, they said, the word, about. That's an easy word, so that'll count as easy. And if it's not one of these easy words, then it'll count as difficult. But you can imagine very naturally that since the 1940s, what we find easy and difficult has changed somewhat, right? So a child today would probably find the word computer very straightforward, whereas they would have found it quite hard in the 1940s, and it's probably something like locomotive the other way around, right? So in the 1940s, probably a fairly easy word, or a common word at least, a relatively difficult word today. But let's talk, more about what concerns us, about these static measures. The first things first, these were designed for education. Right? So if you want to start talking about how society, how culture has become dumbed down, you probably don't really want something that's been trained on school kids in the 1940s. It was validated on children, not adults. Perhaps we think adults have a different ability to, go through the cognitive process of thinking about politics. Also designed for readers in the 1940s and 50s, and as far as we've seen, it's not really been updated since, right? So these readability yardsticks continue to be very, very popular. There's also some statistical concerns, and I know that folks in the room, there's some diversity in terms of backgrounds and statistics, so I'll be somewhat brief here, but if you have questions, I'm really happy to go into details. So one thing that's a bit annoying about this is that if I give you the measure for a given document, it doesn't really mean anything of itself in terms of a fit. So if I say something like, this document here is an 80, right? And that's how I've measured it, right? I don't know if that's an appropriate measurement or not until I go out and test it on school children, right? So and even then the interpretation is very strange because I have to go back to Flesch's original school children in the 1940s, test them, see what proportion of them got above this score on a given test, and so on and so forth. So it has this kind of weird, no ground truth feel to it, right? The other thing that's a bit, I'd say, strange actually about this whole literature, nobody thinks very hard about relative model fit, right? So, when I came in, you guys were talking about, does this model predict better than this other model? It's actually a very important question for social science, right? Especially if we're trying to think about policy. But there's nothing in this literature that attempts to compare different measures. So if you tell me that this particular measure of readability gets different results to this one over here, right? I don't know which one I should use, and there's no way to decide between those two, because again, we don't have the original data that it's fit to. There's no uncertainty around the estimates. So see, somebody will say this tweet is a 70, right? And they'll say this book of 10,000 pages is also a 70. That doesn't make sense, right? Because presumably we have more faith in the one that's based on more data. And then finally, right, there's this kind of weird staticness, right? So we have all this machinery today that can help us think about how rare a term is, relative to all terms on the internet or something, or how rare a term is relative to all terms ever written down or something like that. And it's not really used. So we're going to try and do something about that. So here's what we're going to do in this paper. It's got a fair number of moving parts, but I'm trying to move through, hopefully I'll do a good job of explaining them all. Some are slightly more complicated than others, but in the end, it's very straightforward. So the first thing is, we're going to ask adults to make pairwise comparisons between documents. Our documents are going to be small, but that bit doesn't matter. So the essence of it is, we're going to ask folks like you to tell us, do you find this document easier than this document? Do you find this document easier than this document? And there's going to be thousands of those pairwise comparisons. So in this particular case, it's got 20,000 of those pairwise comparisons. Then what we're going to do is try to predict, in some sense, the outcomes. So what we're going to actually do in practice is we're going to produce a kind of an ability and an easiness for each different snippet from asking these people to compare them and tell us which one they find easier or harder. And we're going to find a way to sort of regress those easinesses on all these variables that we might care about. And here we're thinking about the length of the document, the parts of speech that it involves, the rarity of the words, so on and so forth. Okay? So in some sense, we want all that stuff on the right-hand side. I want all these predictors about what could be affecting how people think about text on the right-hand side, right? And I want to predict the outcomes that they gave us on the left-hand side. Now, the way we're going to do this is with random forests, and I know you guys have been, I think Jennifer was lecturing you about this stuff the other day, so it's maybe it's old hat, but I'll go through a little bit of it in. We're going to find a nice way to incorporate rarity, and we're going to do this via the Google Books corpus. It's like millions and millions of words since about 1580, I think. And then finally, we're going to talk about uncertainty and how we think about basically these basic ideas of sampling distribution. Okay, and what we're going to do in the end is hopefully provide a better measure. So I'm going to start with the crowdsourcing. So I'm not sure, political science is in a bit of a crowdsourcing buzz at the moment. And we're talking about crowdsourcing in sort of two main ways. So it's, how can it help us draw conclusions about the social world? And there we're thinking about, how representative this is the crowd and so on and so forth. For various reasons, that doesn't actually affect our inferences here. We don't care how representative the crowd is. We only care they can make a simple decision. But we're also thinking about the ethics of crowdsourcing as well. What should you pay people? Can you pay them less than minimum wage and so on and so forth? Still, crowdsourcing is the sort of way forward for us in this paper. And we're going to start with this simple observation that goes back at least to the 1920s, which is that humans are really good at telling you about pairs, and they're fairly bad at everything else. Okay, so if you ask humans, do you prefer this space to this space, this space to this space, this space to, and they're really good at that. If you ask them to rank, how friendly they find faces or something like that, they find that very difficult and tiring. That goes for how they're trying to adjust colors. Is this darker than this color? Is this darker than this? They're really good at pairwise comparisons. And probably the sort of prototypical case of this is if you've had spectacles or contact lenses recently, you're constantly given pairwise comparisons. So you're asked, is it better now? Is it better now? Is it better now? Is it better now? And they're just moving between pairs. And it's because humans are good at that, and they're terrible if you give them, say, 4 different lenses and say, which one did you like best? Was it the second one, the third one? Right, they're terrible. Okay. All right. So we're going to recruit thousands of coders, and they're going to do multiple pairwise comparisons. What is a document for us? It's what we call a snippet, which is a 2-sentence segment. Okay. So probably you're thinking that doesn't really feel like what a State of the Union address is, and we agree, but we're going to sort of see how much progress we can make with that and sort of see where we are. Okay? So here's the instructions that you're given on this. And yes, please, yes.
Sorry, can you just say a little more about what crowdflower is?
It's a relatively thin front end that's like mturk, but is, in our experience, a little bit cheaper. And there, in my experience of doing this basically last year, there's less overhead that you pay to the main recruiter, which is the firm, right? So in Amazon, you tend to, I was just discussing this with a colleague today, you pay 20% something. And Crowdflower is the same type of service. It's just changed its name, actually. I literally like last month, and I can't remember what it's called. But if you look up Crowdflower, I'm sure it'll find it. So what Crowdflower does is it recruits all these people to be in their labor pool, and then you put a job on, and then they are matched to the job. And so this is what they do. You're tasked to read 2 short passages of text, judge which you think are easier for a native English speaker to read and understand. And then we were on the fence about this part, actually. We tell them what it means to be a text that's easier to understand. So you can imagine a world in which we basically say, you work it out, right? It's whichever is easiest, but you tell us which is easiest. So we give this kind of prompt to remind them what it means to be easiest, all right? Because that's the kind of the sense in which we want to have it. The one thing I worry about here is that this may have led to a particular type of easiness that may or may not be of interest to us. Okay, so here's an example. I'll give you a second to read this. This is what you see if you start this task. You're asked, identify which of these 2 segments contains easier language. Have a read of those. think B's easier. Yeah, I think that's what the crowd folks thought as well. In practice, I mean, this is in some sense a relatively straightforward comparison. We have some really fine-grained comparisons in there, actually, where even as a researcher, I find it hard to know, what I find this easier, do I find this easier? This one's kind of tough, right? I mean, I'm curious, why do you find this one tougher in general? Right, so the tense is a bit strange, yeah, unusual. No commas, that's right, yes, no commas. It feels like one long run-on, but here you at least get a nice semicolon.
That's a relevant word.
Yes, it's like it's more adverbs, maybe more adjectives, that type of thing, more flowery or something. That's right, yeah. I think this is from the sort of founding days of the Republic, actually. I can't remember when this one. I think it might be Eisenhower. Okay, so we do a little bit of pre-processing, and we basically restrict how large or small the FRE can be on these things. So we want to improve over FRE, but there's got to be some limits. Otherwise, what happens is you have snippets, which are basically a string of numbers or something like that. They vary in length, and the reason we do this is we did a pilot study, and we found that if you give people two little snippets, one of which is just very, very slightly longer, they almost always say the longer one is harder to understand. Right, so, and this is kind of a pain because it's not, always true. Sometimes very short things are, very difficult to understand, and sometimes, very long things are hard to understand. We have to do some sort of randomness in terms of how the pairs work. Just to give you a sense of what people do, so the median coder sees about 18 pairs, you're getting pairs, and the mean sees about 33. So in principle, it should be the case, and I think it's very rarely not the case, that you should never see the same pair twice. Right, so it shouldn't be the case that you see this pair, make a decision, and you see the same pair again. And we make sure that everything's seen by at least two people, typically 3 or 4. One thing, if you're thinking about doing this type of work yourself, you have to put a bit of effort into thinking about what are called screeners and gold standard stuff. So screeners, basically, at the start of something like this, you worry a lot about people, who are kind of low quality or low effort folks, kind of signing up to do these things. So you have to have a screener to sort of check that they are reasonable competence. Although, again, this task doesn't require that much skill. And you also have to put gold standard tasks in, right? So a very common phenomenon in this stuff is that somebody will just go through clicking A, right? And the reason I do this, right, is because they just want the money, and they get bored, and so on and so forth. So we have to put in some kind of gold standard task where we say, we give some sentence, then we say, click B. They click A, and they boot it up the task. Okay, so we're going to have all these binary results, right? So all these people are telling us, I like this one, I like this one, I like this one, I like this one, right? And in the end, we want to make those outcomes a function of a bunch of covariates. And those are things that pertain to what the text has. And the question is how to model this. And it's going to sort of come in 3 steps. And it's a bit unusual the way we're going to do this. So I'll explain it here. If there are any questions, I'm very happy to take them. So we're going to use what's called a Terry model, and I'll get into that in a minute. But the idea about a Terry model for us is going to be to convert these binary responses, i.e., I like this one, I like this one, I like this one, I like this one, and I don't like that one, that one, that one, into a continuous response, right? So the idea here, just to give you a sense of it, is if you're watching the World Cup or something like this, a team wins or it loses. But the question is, we have to order the teams somehow, right? And the way that we do that is we have a score function where we say, if you win, you get 3 points. If you draw, you get 1. If you lose, you get 0 points. That's not exactly what we're doing because there's no explicit score function, but that's the same idea. We're going to get a continuous Y variable. We're going to predict that Y using random forests. So to be clear, for each of these snippets, I know things about it, right? So I know, the nature of the verbs in it. I know the number of nouns it has. I know how long it is, and so on and so forth. And I use all those things to try and predict how it actually did in the context. And then finally, I'm going to sort of make this really, sorry.
Can you talk a little bit about the, I guess, what ML people would call the feature engineering step, how you decide what the important variables are?
I will get to that momentarily, and in fact, I'll have a slide exactly on looking at variable importance. Yeah, so it's a good question. So one of the reasons, in fact, that we chose random forest is because it has this very natural variable importance measure that drops out of it. For us, we want to have a really parsimonious model. So we want to, in the end, be able to say, here are 4 things that you should sort of consider if you want to put these things together. But more broadly, what we're trying to do in this paper is think about what we would call a workflow. which is that for your own problem, right, you want to go through these steps and decide, how many important variables do you actually want? If you want to have 10 important variables, right, that you can fit to your model, that's fine with us. We want to have fewer than that for various reasons, but that would be fine. Now, and the way that variable importance is done in random forest is by this. So two ways to do it. It's either a reduction of the mean square error that comes from a regression approach, or it's a reduction in what's called node purity if it's a classification approach. Now here it's a regression approach. Okay, so I'm not going to. This is sort of a reminder if you've already seen this type of model, and I won't spend too much time on it, as I think it's one of these things that's useful to do, the algebra maybe in your own time. But it begins with a very simple idea, which is that if you think about two people playing, so two teams playing in the World Cup, what is the probability that one of them wins? Well, a very sort of basic, idea is that it should probably be the ratio of their abilities in some sense, right? So there's some notion that if you're really good as a team at playing football, soccer, as it's also known, then you are more likely to win, but that should be countenanced in some sense by the fact that the other team is quite good at football. Okay? And there's some notion that it's that ratio that should sort of tell us how likely you are to win. The question is, how can we kind of estimate those abilities? And it's the Bradley-Terry model that allows us to go from having these pairwise contests to getting, exact estimates on those alphas. So the way that it's done is that we take the log of these alphas and we call it lambda I, and we're going to estimate lambda I basically from the data. So just a quick aside here, how would you do this? Well, in R, you can do it in Bradley-Terry in 2, or lots of packages to do this in. Something that's quite annoying actually in this data, although it doesn't arise too often in our data, is a problem that's called separation. So very occasionally, there's an issue where one snippet is really easy and it always beats everything in comparison. And the problem with that is you can't actually rate it. So again, I'll give you an analogy, right? So imagine that there's a team that's just really good, and throughout the entire history of it playing, it's never lost a game. And the question is, how good is that team? Okay? So in some sense, it's infinity, right? So we don't know. If you give me any other team, the probability that it beats them is 1. But that can only be true if its ability is infinity. Okay, so we don't really like infinity, right? So what should we do about that? And the answer is we do this, right? So we do this first order asymptotic bias reduction, which is known as first exposure, first correction. This is a particular way to penalize the PMLE. Another feature of this stuff is that we need what are called connected designs, right? So this is a very popular talking point in England every time there's a World Cup. Let's suppose that England gets knocked out at the quarterfinals, right? How good is the English team, right? So I think that's an interesting question because it never got to play certain other teams, okay? So maybe it could have been better had it been in some other route to the quarterfinal, something like this, right? But the minimum that you need is what's called a connected context. So there has to be somebody that you played that also played somebody else that played somebody else that played everyone else in the game, something like that. And that's the sort of minimum requirement you need to get kind of reasonable estimates. You can't have a little, league that's playing itself and there's no one to compare them to. Okay, so here are the variables. There's a lot, as you can see, and they're all going to be really highly correlated, right? So you've got count of words with more than 1, 2, and 3 syllables. Count of words with blah, 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 blah. You can read them. We have rarity, which we'll talk about in a second. So we've got a couple of measures, one from the very famous Brown corpus, and we'll talk about the Google Books corpus in a minute. And then we've got parts of speech. So this is novel to us, okay? And this is novel too, right? So you guys have been, I guess, using STM today, very nice, clean piece of software as written by Brandon. It doesn't, as far as I know, have too many call-outs to other software on your computer, so I think it's all done within R. If you want to do things like count nouns, verbs, and adjectives, unfortunately what you have to do is write R code that calls out to Python and does this in the background, basically. So what our software does is does this for you. So in fact, even if you weren't going to do the sophistication stuff, it's a very sort of fast way to kind of calculate these proportions. Okay. And we have the number of clauses. We think that the more clauses there are in a sentence, the harder it is to understand. Okay, So we're going to put these 27 variables on the right-hand side. And the question earlier was, well, how are you thinking about feature selection, right? Which features matter? So we use random forests, I mean, partly because they're fast and efficient. I think you had some discussion of this yesterday, right? But they also come with this pretty low risk of overfitting. So constantly, obviously, we're thinking about this bias variance trade-off. Random forests generally play safe, right? So they don't overfit. They also, and this is really important for us, tell us how important each variable is in a somewhat natural way. So this is the kind of plot that we get out from random forests. And what we're looking at here is how important a given variable is over here on the left-hand side. So we've got, say, for example, the mean number of sentence characters was very important. Okay, so it's basically as important as the rarity measure, which I'll talk about in a second. And then we've got things like the proportion of nouns, which is the third one, right? And then it kind of goes down. In some sense, it's up to you when you make the cut, right? So it's not crazy to basically say, oh, okay, well, I'm going to cut it up to 2. These are the two most important variables. I want 2 variables in my regression. That will do, cut it there, right? Or maybe you cut it up to 10, or you could think about how this importance plot flows or something like that, right? Cut it at a threshold here or something. So we'll talk about that in a second. So broadly, what random forests likes are the minimum Google book rarity, which we'll talk about in a minute. It likes mean sentence characters, and it likes noun proportion. So basically, more nouns that are in a sentence, or in a snippet, sorry, it tends to people like those. We also found that if you add mean word characters, which is basically a measure of how long a word is, that tends to improve the fit. So that's in there for us as well. All right, so to sort of consolidate now, what do we have? I've got a bunch of variables, right, which I think are important. And in particular, I've selected these 4, and I think these are the ones that I want to have in my model. Okay? But the question is, what is the coefficient on those variables? How do I use those variables to produce a new score, essentially, a new ability for every single text that you give me? And the answer is via something called a structured Bradley-Terry model. So we've used Bradley-Terry sort of twice today in sort of 2 somewhat different contexts. But here what we're trying to do is say, let's take the sort of simpleness or the easiness of all these snippets and predict it using the X's. And the key thing now is I'm going to get these betas out, right? And that's going to enable me, every time you give me a new document, I can calculate those X's and I can immediately tell you how easy or difficult it would be. Okay? All right. Here's some throat clearing for referees. So then referees reading this. You don't need to worry about modeling correlation across contests, and we're not fitting fixed effects for the judges because it's a massive hassle, and we've already written the paper and you don't need to do it. So, yes. So
just to clarify, you picked the 4 variables and now you're fitting a structured model back on the original data.
Correct. Yeah. That's exactly right. That's exactly right. So we found the 4 variables using the unstructured model, and then we're going back and refitting to the original contest data. That's exactly right. So this is one of our contributions here, and it's that we're introducing the Google Books corpus, which is a measure of rarity. And so it has a lot of words, 155 billion words, from 1550 to 2008. So as far as I know, they kind of stopped collecting these books in 2008, or they stopped scanning them, or they stopped compiling the word list in 2008. That's probably fine for our purposes, although I don't know if that will still be true in 20 years, right? So what is a frequency of a word? It's essentially how commonly that word is used relative to the word the, right? So the word the is fairly constant, right? And we're asking, is this word used more or less frequently than the, and how much more or less frequently? A lot of cleaning we had to do, which I'll clarify in a minute. And in the end, we end up with 2 variables. So we have a kind of minimum rarity, which basically says how rare is the rarest word in the snippet, right? And then we have a kind of an average rarity, which is sort of, if you look at all the words in this snippet, what is the kind of mean rarity relative to other snippets? So I don't find the Google Books corpus, we didn't find it that easy to work with, actually. And you have to do a lot of cleaning. So this is a sort of classic problem in the Google Books corpus. So this word, stupid, is very common until about 1810, 1820. So what's not very common, it's somewhat common. Why does it suddenly, why do people stop being for stupid in 1820? And yes, typography, and in particular S, right? So how did we used to write S before 1820? You use it every day in your mathematical stuff. Script S, like an integral, right? So if you read old books, it's all this kind of, this kind of long S that to us looks like an F, right? And so if you go and look at like a graveyard in sort of 1800s or 1790s or something, and you're kind of reading off the name, you sound like Daffy Duck or something, right? But that's right. So when it's put through OCR, that's often translated into being an F, and actually it's really an X. And so this stops being an error after about here. But that's just to give you some sense of sort of how annoying it is it is quite annoying to work with this data. It's a lot of cleaning. It took a very long time to clean it for our purposes. So what we ended up doing is, if we find a word like this, which can't be matched to a broader dictionary of words, then we kind of throw it away, right? And that also has the consequence that it gets rid of kind of very rare proper nouns as well. Okay, all right, so we'll talk about the results. And we're gonna sort of compare 3 or 4 things. So we're going to take our model and we're going to start out by saying, well, how does FRE do, right? So if I just use the flesh reading ease of each of these snippets, how well do I predict the results of the context it's involved in? And the second thing is, and this is a bit subtle, so I'll explain this. So you remember when I first talked about the FRE, when I was thinking about these school kids that Flesch was working with, right? It was a bit, he got these coefficients and he said, right, these are the coefficients and it's fixed for all time, go forth with these coefficients. In principle, though, we could fit those locally. So we could say, let's use the 2 things that Flesch thought were really important and have the kind of beta hats that we generate locally, okay? And then we're going to use this very basic random forest model, and then we're going to use what is essentially our preferred model, which is that we're adding in the mean number of word characters as well. So I'll just give you a sense of this. So here we are with the FRE, and so that these pluses and minuses are just what effect does this variable have on ability, which here means does it make it easier or not? So if it's plus, we're saying more of this makes it easy. Okay? So in the FRE model, right, obviously, as we add things which have higher FREs, right, it's going to tend to be easier. And then mean sentence length and mean word syllables makes things harder. Okay, and then we've got the random forest model. So this is as expected in some sense. So things which have fewer very rare words tend to be easier. Things that have shorter sentences tend to be easier, and more nouns tend to be easier. And then finally, this is our sort of best model, right? So here we're recording the AIC. You see that, and these are, I mean, well, I'll talk about this in a second, but this model is doing better than these ones, right? In the sense that it has a lower AIC, right? So its fit is better. I mean, these aren't huge differences, to be honest. And furthermore, in fact, this model, the random forest picks out first time, doesn't do as well as a kind of locally fitted model. So one issue for us is how to think about model performance. So it's not, what's the baseline of performance? It's actually not 0.5, and that's not as obvious as it first appears. So a problem that we have here, right, is coders often don't agree, if that makes sense. So basically, if I give 3 people this thing to code, sometimes 2 people say, yes, this one is easier, and the other person says, actually, no, the other one is easier. Right? And then it's hard to know what a machine should do when it meets something like that. We want the machine to tell us, is it easier or not? But it wasn't the case that 100% of the coders agreed, if that makes sense. But the machine doesn't get to return a 2/3 number. It has to return a 1 or a 0. Anyway, so it's sort of just an interesting problem. And so we sort this out in the paper by basically dividing out by kind of how well humans do on average. And then we do some bootstrapping, talk about the proportion correctly predicted. So I'll get on with that and show you this. So what we're looking at here is for each of our models, we're asking what is the proportion correctly predicted once we correct for this weird agreement problem. And then we're asking if we kind of resample data and fit the model 1,000 times, right, how large or small is the confidence interval around that. So the main point to be made here is that in general, our model, in terms of its kind of point predictions, does the best, right? So it's about 0.75-ish or 0.741 or something like that. But more particularly, right, it's actually outperforming the original FRE model, right? So what we're saying here is that these 2 confidence intervals don't overlap, okay, and they're actually not that close. So we're saying that this is a statistically significant difference in performance, right? So if you're thinking about using this model, even if you're doing it in our particular setup, right, you should just do this model instead, at least for the type of data we were using. Okay, so you might think, why do we actually beat FRE? It's basically this type of thing. So, here is Cleveland, I think, right? Yes, and he's talking about something that's not that complicated, but he uses this, what is now a very unusual term. You'd be surprised to see that in the State of the Union today, right? Obama actually, that's actually, once you take this word out, they're extremely comparable in terms of how difficult or easy they are. But it's this very rare word by today's standards that make that speech much harder. And so we're going to almost do better than FRE because FRE can't take that into account, basically. Okay. All right, so maybe it seems like a lot of work, and you're thinking, well, I don't really want to do this. I don't want to spend 2 days of my life trying to do an install of some Python dependency or something. But let me tell you, it's a very rewarding 2 days. So you might think, well, I don't really want to do this, right? But what I would say is that a nice feature of what we're proposing is that it's going to give you something that's meaningful in some more philosophical sense. So here's a couple of speeches, one from Eisenhower, one from Bush. Now, I'll just give you a second to read those, actually. It's not critical for what follows, but just to give you a sense of these. This worked out great. Anyway, so Eisenhower and Bush, right? And the question is, right, which is harder, right? Well, sometimes that's maybe it's this one, maybe it's this one. We sort of want something more than that, right? We want some real precise quantification of how difficult one is relative to the other. But that's easy for us in this model, right? So all we have to do is plug in the various values, multiply them by the coefficients, and we can estimate, this is how hard Eisenhower's speech is, this is how hard Bush's speech is, and this doesn't seem to mean very much, it's just the estimates of the lambdas. But we can always talk about probabilities. We can always say something like, what's the probability that the Eisenhower snippet is easier than the Bush snippet? And that's well defined for us, right? So we're not talking about this weird thing of like, oh, this was 70, this was 72, or something like this, right? This is kind of a meaningful estimate. We talk about probabilities. So, if you think about the coverage of the World Cup, and something like on Nate Silver's site, they talk about this team has 6% chance of winning, or something like this, and that's exactly what this is doing here as well. So we think this is kind of a proper framework for thinking about comparisons of something like easiness. Okay, we do some uncertainty stuff, so we find a way to do a bootstrap that enables us to think about how uncertain we are. Notice here, by the way, so this is our estimates over here, right? You'll notice some of these confidence intervals are really wide, and they're wide basically because some of these speeches are really short. So you just don't get much information, right? And it's, if speeches are getting much shorter over time and they're getting much more uncertain over time as well, right? You want to be careful about saying this is easier or harder or whatever it might be. So sort of finally, we have these dynamic estimates. So a nice feature of what we're doing in this paper, I think the nice feature is that we can adjust the rarity measure to the decade that you're interested in. So there are obviously words which were relatively common in, say, the 1820s, like husbandry, like animal husbandry, which are relatively rare today. But in some regards, we don't want to use today's understanding of how rare these words are to assess how difficult the text was then. Obviously, all the people who would have listened to that text or have read that text are now dead. We can't ask them directly. Well, maybe the closest that we can do is to adjust for how common the word would have been at the time. And what does this do? The net consequence of this is that it makes earlier texts look a little bit easier, right? Not much easier, I must say. So they're in general harder, but it has this dampening effect. They don't look nearly as difficult because basically you're adjusting for the fact that those words were actually relatively common then, and they're not so common now. We'd actually like to do something like that with grammar. It's actually very difficult to do. Okay, so sort of wrapping up, right? I think sophistication and dumbing down is a sort of very important topic in some sense, right? We talk about it all the time, but we don't have a really good way of measuring it. So in this paper, we've given a new workflow. It's completely integrated with the statistical framework. So if you like to think about things like confidence intervals, right, around your measurements, if you like to think about sort of meaningful interpretation of how hard or difficult something is, right? This is the framework for you. And we want to think, going forward, I think we want to think more carefully about sort of what is sophistication and what is complexity. So here, you know, we as I say, kind of hand wave out these things, but that's something we want to kind of move into. So software, there's some software called sophistication, okay, and that's already live and ready to go. So you can download it. It's an R package, and it's part of Quantita. I'm not sure if you guys are using Quantita, but that's a kind of an R front end for text analysis. And this is fast, and it will help you do the Python install. There's a dependency called spacey R, but that's apparently relatively simple. I think I'm the last person in North America who's using a PC. It's slightly harder on a PC, but you're all educated elites, so you're all using Mac products, where it's apparently relatively easy. Okay, that's it from me. Yeah, drop me a line if you have any comments, and that's my website if you want to use me. So.
Did you end up running the State of the Union pages using your readability index?
Yes, we did. That's right. So, and it looks a bit like this, actually. So, this is the original FRE, although we smoothed it here. So this is what FRE would look like. So, generally speaking, we end up saying that the current ones are probably a little bit easier than FRE thinks they are. And the old ones are actually a little bit harder, although this is highly tempered by the fact that a lot of these overlap, right? So, if you look at something that was talked about in 2000 or 1999, right, you look at that confidence interval, it's overlapping right back to sort of 1900 or so, right? So it's not as different as you think it is. So we end up, our story about dumbing down is sort of, I don't want to take too strong a line on this. So in any case, we think the State of the Union is kind of unusual, right, relative to other cultural texts, to be honest. But our story would be sort of, it may, at the point estimate level, maybe it is a bit simpler now, but it's hard to say.
Thank you for this. Been working on a project looking at variance in regulatory complexity.
Mm-hmm.
You're struggling to develop the right way. So what extent do you think this could help actually have that?
So my understanding of this literature, and you're obviously the expert, so you can correct me, is that a lot of the basic measures sort of boil down to things like how long is this thing, right, something like that. And it might be getting longer over time, but it doesn't necessarily mean it's getting more complicated or whatever. So I would start with something like this, see if it works, right? So a meta comment here is that if you don't know it when you see it, no method can help you, right? So if you don't know what is a picture of a dog versus a cat, right, it doesn't help to have a machine try and tell you, right? And the same thing is true here. So this boils down to saying you should validate things. So basically, if you don't know what feels simpler versus what feels harder, it won't, in this regulatory framework, there's kind of nothing that can help, right? If you do, you can at least run it through some basic models like this and sort of see if it helps you. And the way that we've built our software is that you can always, the baseline is arbitrary. So if you want to do it relative to a 5th grade text, you can. If you want to do it relative to, I don't know, the 10 Commandments, you can do that as well. And it will always give you that estimate relative to a baseline. So my sense is to try it. The other thing that comes to mind, though, as you say that, is I wonder if it's one of those things, certainly, that you could try crowdsourcing, right? So at least to give you a sense of what do other human being users think of as being kind of easier or harder. I mean, again, it's not just the model I'm trying to sell people on, it's also just the workflow of kind of asking real humans, which do you find simpler?
So can I ask you just a follow-up question?
Yeah, please, yeah.
The outsourcing or the crowdsourcing. We thought of that, but then part of the question is, who's the right judge of this? I mean, is it a lawyer who has experience with this? Is it someone off the street? Right? So you're a little hesitant to just rely on the crowd assessment. I'm not sure that captures what, but maybe it does.
This is a sort of fundamental question about crowdsourcing. And there's a very nice paper by Benoit et al., my co-author with some other co-authors, not me, last year. And they tried to draw this distinction between wisdom of the crowd versus sort of a coding exercise. So in wisdom of the crowd, it's that there's a notion that there is a correct answer out there, and you know, that you can recover it, or you know, or something like this, right? That, you know, the way that the question as to what you're trying to represent with your crowd is a fundamental one. My advice, I guess, is to see how it works relative to the expert judges. So in these experiments that my colleagues did a year ago, or over a year ago, where they were looking at manifestos, they find that the crowd does just as well in some coding sense as experts do, because they're given a really, really simple task. Now, that may have not been the case, of course, but that's what they found. And so I guess my hunch is to sort of try a pilot scheme like that.
Could you just say a little bit more about how you did the adjustment by decade for word rarity?
Yes. In the end, every decade, think about slicing up the corpus, this huge corpus into 10-year chunks, right? And so if you say, I want to know how rare the word husbandry was in 1810. So for us, that question boils down to saying, how rare was it from 1810 and 1820? That's a minor point. It's going to basically go off and find the corpus, all the words that were between 1810 and 1820. It's going to look at the rarity and divide out by the contemporaneous use of the word the.
Oh.
So it's going to sort of ask how rare was it relative to a very common word at that time. That's what it's actually doing.
Yeah, 2 questions. So should I be concerned that part of the trend that you're discovering are given by the substantive issues that you're talking about, rather than the linguistic say? So have you, I don't know if when you do the crowdsourcing, can you fix the topic, like pick the 2 acts of the similar topic?
Yeah.
So that's what get up.
Yeah, so no, it's a good question, right? So the we picked the State of the Union on the basis that we felt that the topics were somewhat constant over time. If you really want to keep them constant, you should do kind of contemporaneous kind of comparisons, right? So only compare the ones in the 1950s with each other, or snippets or something like that. But no, we don't make an attempt to control the topic. So our assumption is that the topics discussed, at least in the State of the Union, are already fairly basic. It's just the way that they're discussed. There's actually an interesting question about, I'll give you an example. So people often say, 2016 is evidence of a dumbed-down election, right? So, people worry about Clinton's emails and so on and so forth. Right? This is evidence of dumbing down. Okay, so first off, to understand an email scandal, you have to understand what an email server is, right? So I don't know how, I don't know how well these kind of butter emails folks understood that, but you have to have some understanding of what that means, right? And it's actually a fairly complicated thing relative to, say, political debates that maybe took place in the 1960s, which boiled down to basically, well, I'm not going to vote for Kennedy, or Kennedy's Catholic, right? Something like this, right? Now, I mean, okay. So Hillary Clinton, obviously, there are some other demographic characteristics that people didn't vote for her, but I think it's. I'm skeptical that things are becoming dumbed down in terms of substance.
Second question.
Yeah.
Yeah. So when you do the model,
yes.
Is there a way to borrow information within person to check the consistency of traceability, like A?
Yes. This is all right. Okay. So this gets into this very thorny issue of basically judge effects, right? So essentially, our code is consistent, our code is good, right? Do they have particular preferences? So maybe there are coders out there who they just really like nouns or something, right? And they're just really unusual, but they do a lot of coding, and so So we don't look at that, and there's going to be 2 defenses to that. So the first is as an empirical matter. In this other paper in 2016, 2017, the folks who are working on crowdsourcing, they do fit some judge-specific effects. So they basically say, what if we control for the coder? And we see sort of how good coders do and all this sort of thing, right? And they find it doesn't really have an effect on the end result. So we're going to kind of hand wave and say, okay, that's enough for us. The second issue, which is a more philosophical one, actually, is this question about IRB approval, right? So the way I approach the crowdflower stuff is that these folks are helping us code things. They are not the subjects of an experiment, right? And that's important because if they are the subjects of an experiment and you're publishing things about these people who are doing this work for you, then you should seek IRB approval because they are your subject matter, basically, right? But they're not our subject matter. They are simply some RAs helping us code things. Whereas if I have some undergrads, other than if it's I'm going to give them a stimulus which is offensive or obscene or something like this, right? I don't need to get IRB approval. They're just coding things for me. And that's how I view the crowdsource workers. Now, I think that when you start trying to do kind of looking at the coders and looking at what their fixed effects for coders should be, I think you're moving towards a world in which they are becoming the subjects of the experiment, and I think one should be cautious about that.
What I actually meant is like the inconsistent, like if someone rated A harder than B and B harder than C, then if that question pop up again, that person should rate A greater than B.
Yeah, okay, so yes, sorry, right, so these transitivity tests, right, so yes, the Bradbury model assumes transitivity, so I didn't do any checks in that sense. I am wondering, yes, we didn't do anything like that. One thing is, I'm not sure what I would do with the information if I had it. Right? So would I throw them out? Possibly. Possibly. Although that even strikes me as something where, in some sense, it's informative about how hard it is to make a decision. See what I mean? Right? It's like, that's actually informative, because it means these two things are not as different as I thought, something like this.
I have a question about when you were assessing model fit.
Yes.
Why is it that you chose to assess model fit in sample rather than, unless I misunderstood something, rather than run like a horse race between the models on some text that you had held out from the model that the data that you fit?
Yeah, so we could have done that. So yeah, I did think about that. So in the end, I decided instead to do sort of bootstrap results during sample, right?
Yeah.
But at least that's giving some sense of standard errors, right? So we're going to kind of randomly sample through our data. So one thing about out of sample testing, I think it's not trivial to decide what the splits should be and that sort of thing. I think that's a weak defense, I guess. But I felt that once we've done the bootstrapping, it was enough.
Because what I meant is like on one of the slides, when you have the Bush-first Eisenhower comparison, it generates a very intuitive, as you were saying, measure of what's more sophisticated, what's more.
Yeah, that's right. That's right.
And that to me seems to invite an easy test in some ways. If you have
no, that's right. That's right. And we could have done that. So we could have had a holdout sample. We could have said, well, we're going to have a bunch of contests that were done. We won't look at them until we fit the models. There was a referee actually that suggested that, and we kind of ignored it and sent the paper back now. So I hope that referee isn't watching. So in the end, I felt the bootstrap was kind of fine. But it's a very reasonable point. Yes, could have done that. One could do out of sample. Yes. If I was doing my life over again, maybe that's fine.
Yeah, very simple question. Have you tried out maybe a multi-dimensional model? So right now, the probability is assumed to be like a unidimensional line.
It is, yeah.
So, but in principle, I think you could with 2 dimensions, but look whether the second dimension is like meaningful.
Yeah, so that's right. So we assume that ability, we're assuming a lot of things, right? So we're assuming that it's a linearly predictive process, right? That you can just take these x's, multiply them by beta, and that's going to give you ability. So it is true that humans generally don't find this an easy task for a lot of the comparisons they're asked to do, which may suggest that they're judging it on different dimensions, basically. I think that's to be honest, sort of a future work problem. We were just trying to give and it would fit into our workflow in some sense. You could do sort of two-dimensional things. It's just, it's not what we chose to do. I have a feeling that the other dimension is basically error, right? So I think it's just really hard to do. And so I think I suspect it would be overfitting, is my guess, yeah. But I agree in principle, yeah.
So when you get like a block of text, you guys have theoretically informed idea of what the relevant features from that text are to predict this, in this case, easiness, the outcome variable. But is there a way to, I mean, I have very little experience with this, so I'm wondering, is there a way to approach that problem in a more unsupervised way to extract features from the text? Or to...
So this is, so this is a sort of, so I'm at one end of the line in terms of my views about where features come from. Okay, so so basically, I still believe in theory, essentially. So I think that features come from theory, right? And I think things like big data revolution it's not exactly there, but it's very close to meaningless in the sense that without theory about what features should matter, I just don't know what we're doing anymore. So the only way I can think of it is something like I think you can always add features, but you have to do some transformation to understand what you should be measuring, what you should be what you should be doing, and so on and so forth. So I have this, and I'm glad I wasn't here too early because I know you guys did a topic model today. And so, so I'm of the mind that humans are really good at abstraction. So, think about star science or something, right? So we put these stars and we say, oh, this is the plow, and actually also looks like a bear, and this is Orion and the giant, and so on, right? So, so what is that? That's a human ability for abstraction. We see some things, some features, and we say that is actually this other thing, right? So my very cynical sense is that a lot of what goes on in topic modeling, unsupervised modeling more generally, and people fit a topic model and they have an ability to just interpret what they want out of what they get. And they're like, oh, there we go. So that tells us that, in fact, this was a current in, this type of philosophy from this year to this year because it came top, and I'm going to interpret it in this particular way, right? So I have become very skeptical about atheoretical things, and I think a lot of topic modeling that goes on is atheoretical. And so when I'm asked kind of what features should I use, I'd say there should, at a minimum, be some notion of theory here, right? I mean, you could, in principle, what we said is you could throw anything you like at it, right? So you could have, I don't know, like the number of seconds or milliseconds it takes you to read it or something like this. It's all features. But I guess I think there should be some theory, yes, yeah.
Cool. Thank you
very much.
Yeah. So we're all done for today. We'll see you tomorrow. Tomorrow we're actually moving and we'll be using some MTurk tomorrow. So there's no transition here. We'll be surveying MTurk. Oh, I'm gonna Slack a day 3 survey for you guys. So maybe